what is artificial intelligence? Now, let me start from what is intelligence. But before that, we have certain sensory organs, right? Every human being has certain sensory organs. Eyes, through which I can see; ear, through which I can listen; tongue, I can speak; nose, smell; skin, feel. This is these are sensory organs of every human being: eyes, ear, tongue, nose, and skin. Now, of this three out of five, these three can also be there for a computer. Eyes. A computer eyes is nothing but the camera or the video which can be attached to the computer. Your mobile phone is a computer, and all of you have eyes to your computer, the video or the camera. Basically, that comes under vision. Ear, it's all about listening. I can listen to ears. And tongue is for speech. I can talk. So, eyes, ear, tongue are the three sensory organs which a human being has, and so a computer now has. Tongue is as good as the speaker. The You're listening to me actually through the computer only. You're listening to me, and as well as ear. I'm talking and you're listening. So my data, the voice, is being converted to digital form, going through the network at your end, and the digital is again being converted to a form through which you can listen. So basically, computers have this capability of seeing, vision, talking, the speech, listening, and definitely because of these, language and decision making is also possible. So obviously, there are certain things which every human being is going to perform on a day to day basis. We actually predict. You can predict rain. You will say, oh, maybe it's going to rain after some time. You might predict a price of a stock in the stock market. You can probably sometimes predict the result of a game, cricket, football. You do prediction on even what kind of yield I'm going to get from the land, soil, based on the soil strength. So, on what basis are we predicting? Definitely, there is some intelligence which is coming into the play, and this intelligence is working on the basis of some past data, some past experience. So, I have seen the price of a particular stock going up and down based on multiple parameters: the amount of profit the organization declares, the circumstances around the product of that particular organization. It can be influence of politics, it can be influence of nature, so many parameters. I will look into so many parameters and I can say, okay, tomorrow the price of this particular stock is going to be so and so. The yield of the crop is also going to be based on many parameters. What is the strength of the soil? How much fertilizer I'm going to make use of? The availability of water. So based on these parameters, my intelligence is going to predict something. Yes, based on certain inputs, we are able to predict, and that is nothing but intelligence. So we are actually in these predictions trying to understand or recognize some standard patterns. We are finding a pattern. And through this pattern only, we are saying, okay, if this is how the parameter A, parameter B, parameter C, parameter D are, this is going to be the result. This pattern we are going to predict. The pattern can be used even for on the basis of my weight, my living standard, what I eat, how much I exercise. There can be a prediction that I may be diabetic, I may not be diabetic at a particular age. But the human intelligence also has certain knowledge, like there can be certain abnormal events, there can be some things which are probably going to be different because of certain special factors. And because of those special factors, the result is going to be different. It's not like always 2 plus 2 is going to be 4. There will be one more factor here which is going to impact the result. For a given input, you may not always get the same output now because there can be certain variations. I am probably overweight, but if I am pretty active and doing my exercise, there is a chance that I may not get diabetic at a age which probably is a standard, which has been observed pattern in many other people. So human intelligence comes in that aspect also. So what is artificial intelligence? When computers start thinking like human. Simple. If a computer starts thinking like a human being, if a computer starts predicting outcomes based on the patterns which it recognizes from lot of historical data which is given to that particular computer, the program, ability of a computer to also find out what are the abnormal events which can make it deviate from the standard result, standard outcome. Yes, computer now has the ability to interpret visual things. Computer can say, okay, I am walking. Basically, you know pretty well Tesla car. What is there in Tesla car? Without driver, how can it drive? Because car is now given insurance. No, but it's not the car, it's a program inside the car which is given insure, which is given the vision to see if there are any obstacles, if there are objects coming in front, and accordingly varying the speed or probably halting or increasing the speed. I mean, driving is nothing but artificial intelligence. Ability of a computer to convert the text of one language into another language, or ability to respond to my questions. The bots are nothing but I ask a question, and based on the question they are nowadays giving the answer, automated replies to the questions. That's nothing but artificial intelligence. We all communicate by writing, by speaking, or engaging in some dynamic conversation. So can the computers now. Bot are the best example of that. So, like a human being has a brain which is being trained. with experience, with time, based on so much. Imagine now a child is born, and if that child is kept in a room for 20 odd years, the child doesn't go out of the room. Do you think the child is going to become intelligent? Will the child be able to predict things? Will the child be able to even move for that matter? No. Why? The brain did not get the required training. So now we want to talk about how a computer can be trained. The intelligence of the human being is now being provided to a computer, and that is making computer predict and make decisions. Like our knowledge grows, the knowledge of computer also is going to grow. How? More information. Ability to process my information properly is on the basis of the knowledge. So is the thing which we want to do it with the computer. So artificial intelligence is all about making computers think the way humans can. So there are certain common AI workloads. When you're talking about AI, you should be aware about these things specifically. Machine learning, computer vision, natural language processing, document intelligence, knowledge mining, and something very popular nowadays, which we use it often without even knowing about how it is working in background, generative AI. So what is machine learning? Machine learning, we are learning things, right? As a human being, I'm learning things. So machine learning basically is a branch, one of the branch in artificial intelligence. So if you look at machine learning, it's a subset of artificial intelligence. Keep that point in mind. It's a branch in artificial intelligence which is going to focus on, very focus on the data from the past, of course, all the data from the past, and most important, an algorithm to enable AI. In machine learning, we have to build one algorithm, and that algorithm is going to imitate like a human and provide output for a given set of inputs. Basically, machine learning is all about creating predictive models. And what is a model? In programming term, I can say a model is a function. Like you know, add is a function. An add function, you might pass two integers and it returns an integer. So now we are talking about a model which is going to be trained on certain input, on which it will find out the pattern to compute a particular output. That means we are giving model not only input, we are also telling this is the output. For this input, this is the output. We are telling the model. And model based on this input and output is going to build an algorithm for itself. So there is a huge amount of training data which we are going to provide to the machine learning model, which identifies the pattern in all these inputs which we are giving. It will automatically identify the pattern, and based on the pattern we can start doing the prediction later. So first, using machine learning, we are going to build models, and then we are going to use those models for prediction. Model has to be trained. How is that done? I'll talk about it very soon. So for different types of purposes, we are going to create different models. I can create a model for predicting a price of a stock. I can create a model for predicting the result of a cricket match. I can create a model for predicting the yield from the farmland, agriculture. So, for different types of businesses, different types of sectors, there are different types of models which have to be created. So, that's what is machine learning all about. Predictive models based on data and statistics, which is basically the foundation of the AI. We need that minimum first. Then we are now talking about computer vision. As I said, computer vision is the capability within the AI to interpret the world visually. And how is that done? Through cameras, videos, and images. We have trained the computer with so many images that given a new image, it will find its existing image and predict, okay, this is what it is. Just imagine Google and you go to images tab after putting some message in the Google search. How many images we are getting? Huge number. So Google has all these images and some metadata about those images. And based on that, it's able to take me to a particular URL. So what Google can do, use all those images and the metadata and create a model saying that if the image looks like this is an apple. If the image looks like this, it is a banana. Because model has been trained, it is already there. So computer vision is that aspect. And it's not only image, it's also about video. The running video is what? Ultimately, images changing very fast. Our eyes will not be able to distinguish that one image is going and another image is coming. But ultimately, videos are nothing but images played very fast frequency. So yes, computer vision is also part of AI. Then we have got natural language processing. What is this all about? Ability to read or ability to write. As I'm talking, maybe some captions can be generated on the Teams. Or maybe I'm talking in English and the caption subtitles are in Hindi, are in Telugu, are in French, are in Spanish. That's the power of natural language processing and many more things we are going to discuss one by one. Document intelligence. What is this about? Imagine there are 10,000 invoices. My business has collected 10,000 invoices in a day, making different types of sales. And now I want to automate all these invoices. I want the ability of my computer to scan the invoice, automatically read to whom was the invoice raised, what was the number of items sold, how many number of items are sold, what is the total price, and create a database table out of it. Or in simple language, ability to just take input as a visiting card and create my contacts list, updating a contact list through a visiting card. Those kind of things we are going to do with document intelligence. When the data volume is very high, we don't want to do things manually. And when we don't want to do things manually, document intelligence can help us to scan the data, read the appropriate information, and fill in into the appropriate fields of a given database table or present it to you in some other format in which you are interested. That's what is document intelligence in AI. knowledge mining, huge amount of unstructured data you are taking, or in layman's language, I'm saying search facility, ability of searching for something in huge volume of data which is not in the form of table, unstructured data. I'm saying maybe there are many PDF documents, many Word documents. There can be tables, there can be JSON documents. You want to be able to search in all these things and provide results, knowledge mining, indexing, and the last, the generative AI. The moment we say generative AI, the first thing nowadays comes into our mind is chat GPT. What is that chat GPT can give? It can give me a leave letter. Many times I get even resignation letter drafted by chat GPT by the employee nowadays. Love letter also you can ask chat GPT to draft. One of the case I have used chat GPT to console my wife when she was angry with me because I fought with her, told her this is the situation, please help in drafting. Oh, beautiful letter. After seeing, she started crying that I can write this. Poor lady then does not know that it was chat GPT. It can be chat GPT, it can be Gemini by Google. All these are generative AI models which can take the original content, and that content can be text, the natural language, English, Hindi, Telugu, Tamil, French, Spanish, Japanese, Chinese. It can even take images as input. GPT-3 will not be able to, but GPT-4, if you have the paid version, you can give image as input. You can even give input as your code, C# code, Python code, Java code. In all these formats, it can take input, can be image, can be code, can be text, natural language. That means we are giving some content and asking GPT to generate something out of it and return back to us. It can be a image. There is an image generation software, DALL-E, part of OpenAI, Midjourney. You might have heard of these things, DALL-E and Midjourney. You give your specification, they can create a logo of your company. Give your image, it can remove the background for you and give that image. And nowadays, videos can be made without putting lot of effort with the help of something like Sora, video generation input. So generative AI is about capabilities in AI that create the content in variety of formats. It can take input, it can give output in variety of formats. Basically, it can do things which computer vision can do, natural language processing can do, knowledge mining can do. So other AI specializations are all built into generative AI. So what happens is when you're going to build applications, software applications as a developer, you might want to use all these features. Sometimes you might use only computer vision. Maybe there is a software which is optical character recognition. It is reading the content which is handwritten and converting it into the English text, computer font text. Natural language processing can be something like translating data from one language to the other language, Google Translate feature. But there can be certain applications which use more than one of these features at a time. The best example is bot. So bots are conversational AI. You can talk to a bot, right? I go to a bot and say, hey, can you take my order for a pizza? The bot will say, okay, which pizza you want? Option 1, option 2, option 3. I tell, okay, I want a veggie pizza with lot of vegetables and spicy. Immediately it will give me next question. Basically, it's a conversation model. Bot is a conversation model where it can read the text which I am typing, or sometimes it can also listen to the audio. I can talk to a bot on a phone. So bot relies on some natural language processing capabilities. It can be a claim for an insurance. I have met with an accident, my car is damaged. From there, I directly call, and the call is not answered by anybody, any human. It is a bot which is taking the call. And I'll say, okay, I want to submit a claim. I've been hit with another car, or I have hit a pole, or I have hit a tree, or whatever. I want to submit a claim. And then a conversation starts. In the conversation, there is a chance that the bot is asking me, can you please take photograph of your car and submit? So for a damaged vehicle, I submit the photograph. That's where the computer vision API can come into picture and do an assessment of the damage. And maybe based on the damage, it can predict using the machine learning models how much cost it is going to be for repair. The total repair cost can be computed through a machine learning model which has been trained for different parts which are damaged. This is the total cost which is going to happen. And there is something called as anomaly anomaly detection, which a bot can make use of to find out if this is a fraud. So bot is basically doing a conversation with us, and that bot software is using multiple aspects of AI. And bot from this input is again learning by itself, so that tomorrow it can generate more better output. So all these are different types of AI workloads. You might do machine learning in your applications. You might do simple computer vision, natural language processing, document intelligence, knowledge mining, and generative AI. These are all features which we want our software to perform. We want to use these aspects in our software application. But then there is something which is very important. Principles of responsible AI. What are these principles of responsible AI? Ethics, basically ethics. A person is identified by how much ethical the person is. The value system of the person is known, and that defines the ethics of a person. So computers are now given intelligence. And now imagine we start influencing that intelligence, and the influence result we are getting it. No, that shouldn't happen. So what Microsoft did is they defined this six principles. They call it as six principles of responsible AI. Of course, right now these are not the law of the land. But over a period of time, you'll see that the AI is becoming so vast and becoming so common part of our life that the law of the land, the government is going to come up with certain rules on how AI can be implemented and to what extent it can be exploited in various applications. And what are the things it is supposed to take care of. So, what are the six principles? Fairness, first one. Now, what is this fairness? The software should not be biased towards something and generate results. It should not do any kind of discrimination. Imagine a beautiful girl goes to the bank and applies for a loan and she gets it. And I go to the bank and I don't get the loan. Why? Because she is more beautiful and I'm not, which actually has nothing to do with the loan, but on the basis of this parameter, my loan is getting rejected. This kind of thing should not happen. This is not fair. The loan should not be either granted or rejected on the basis of gender, ethnicity, or any other factor that might result in unfair advantage or maybe disadvantage to a specific group of applicants. That's what is fairness. Certain things should not be taken as criteria for the end result. So, gender, ethnicity are most important things based on which you are not supposed to take any decision. A black goes and request for something, they get it. Sorry, or the white goes, they get it. Black doesn't get it. Oh, it's not allowed. The beautiful thing is, all these six principles are already implemented in Azure. What's happening? Okay, sorry. So, fairness is the first responsible AI principle. And the Azure machine learning, I'm talking about machine learning implementation in Azure, includes the capability to interpret the models. How is machine learning going to make decisions based on the models? So Azure machine learning has the capability to include models and quantify the extent to which each feature of the data influences the model's prediction. I mean, you'll understand this little better after I make you. I mean, after I explain you how the machine learning works, which is going to be the next topic. Reliability and safety. The best example is autonomous vehicles. If you know your algorithm is not reliable and safe, don't release it. It is not able to identify certain special types of objects and is causing collisions, system failures. It's your responsibility to ensure that you don't end up releasing applications which are not reliable or safe, which can probably cause harm to the user. Imagine a software which, on the basis of my symptoms, gives me medicine. Now, what will happen if my symptoms are not rightly identified and some medicine is prescribed to me, which probably can have a side effect? And it can even risk the human life. So, your software application, which is using AI, has to be reliable and safe. You have to ensure that it's thoroughly tested for all different types of conditions. Rigorous testing should happen. Rigorous testing to ensure that it's not giving fault results. It's okay to say I don't know, but giving fault result is dangerous and that should be taken care of. Privacy and security, one of the very important things nowadays. I'm giving some input to the application so that based on this input it is supposed to take decision, but that does not mean the software owner is using that data for some other purpose. I provide my age, I provide my gender, I provide my address, and from tomorrow onwards, I start getting emails about the various campaigns based on my interest. No, that means my data got leaked. I try to find out based on certain symptoms what could be probably the disease, and suddenly the health industry starts communicating with me, starts talking to me with various possible solutions. Medical data getting leaked. So your software application is supposed to ensure that it follows all the privacy principles and also should ensure that the data is secured and not accessible to unauthorized users. It's the responsibility of the software developer. Privacy and security, very important principle of responsible AI. Inclusiveness. Everybody should be included in the society. The solution should be for everyone, not for a small sector. It should not be like somebody is visually impaired and for them this particular software is not going to provide solution just because it's visually impaired. There should be an alternative in case the person is not able to read, maybe they will be able to hear, so provide an audio output. So inclusiveness ensures that the entire society is what whom we are referring to as our customer for the application, as our user for the application, not expecting only a limited set of users with special capabilities. Transparency. Every application makes predictions on the basis of certain criteria. Those criteria should be informed to the user of the application. Things should not be hidden. If AI is making a decision, what are the criteria based on which the AI is making a decision? What is the source of the data? What are the assumptions which are made while predicting something? There will be definitely some assumptions, especially in very complicated systems. Imagine my X-ray of the brain is given to the system software and it predicts tumor. I want transparency. I want the software also to tell me what is the criteria based on which it is able to predict tumor of the brain. What are the factors which are deciding tumor of the brain? So that's what is transparency. And most important, always an accountability has to be attached if something goes wrong. Who is going to be responsible? Imagine, I mean, I was surprised in my family, few ladies were feeling so happy when they were able to change the face in one of the applications they saw. They are able to change the face of a model and put their face, and they started playing like a game. Immediately it clicked. Damn it, somebody can be now. I mean, video is no more a proof of some action now. I can steal something and I can replace my face with your face, and the system identifies you as the culprit. Who is going to be responsible for such kind of things? You have to be accountable. So any kind of AI decision which is made, there has to be accountability. Somebody has to take the responsibility of that decision. So these are main six principles of responsible AI. You should be fair. Your decisions should not be based on ethnicity or gender or any other such parameter. The applications should produce reliable and safer result which will not harm the individuals using the application. The data inputted into the application should not be revealed or shared and should not be hacked. It should be highly secure. You may encrypt and keep it. You should ensure that you are going to include all the different people of the society and not creating exceptions. Remaining transparent on what were the assumptions made while making a decision, and attaching accountability for any kind of AI decision. All these are principles of responsible AI. So we understand very clearly now what is artificial intelligence, what is different type of workloads, how can my software application become more intelligent, what aspects of AI I can use, and when I use this, what are the responsibilities I'm supposed to take care of. Principles of responsible AI. So now that we understand AI, what is machine learning? The first thing in AI is machine learning. Creating predictive models by finding relationship in data. See, in machine learning, we are always going to do some kind of prediction. And the very purpose of machine learning is prediction. Prediction has to be obviously based on some input parameters. So what we do is we train a software. We are going to train a particular software so that for a given set of inputs, it can identify a pattern to achieve a particular output. That means, as I told you earlier also, we are going to provide some kind of training data which is nothing but past observations. So I'm saying this x1, x2, x3, if is given, then the result is supposed to be y. I know the result already. Got it? If so much amount of rain comes and this is the quantity of manure used with this much richness of the land, this is going to be my prediction of the crop quantity, the yield of the crop. And in the past, I have achieved that, and that I'm going to input it. Various combinations I'm going to provide. So this is called as training data, wherein X1, X2, X3 are further categorized as features. I have so much of weight and I live in such a specific environment with so much pollution or other factors and many such kind of things based on maybe I'm alcoholic, non-alcoholic, I'm smoker, non-smoker, many such parameters, my age is calculated. Or probably the kind of disease I'm going to get is calculated. So these are features which have been observed in the past, and for these features, this is the result, which is referred here as label. So you have to remember what is a feature and what is a label. Feature and label. When these features and labels, maybe in a form of Excel file or maybe a CSV file or some table or data from storage, when we give this as input to an algorithm, now algorithm is going to train itself on this data, and obviously during this training it is going to have one additional factor which will impact the result, which will, there is one unknown factor always there based on which the result is going to change. So the algorithm is going to be applied on the data to try and determine the relationship between all the features and the label, and it's going to generalize that relationship between x, which is a vector. This is a vector. Vector is nothing but an array, actually array of multiple values. So x vector and y, there is a algorithm which is tuned for this x, how to achieve this y. See, now it is like this: x comma y is equal to z. Now I know x and I know y, I know z. Can I calculate? Sorry, I know x and I know z and I want to get y. Is it possible? Simple mathematics. So the algorithm is going to be trained for the feature and the label. How this is training happening, we'll see later. And a function is going to be the result. And that function is what is a model. A model is a function. Remember this. A model is a function which for the given x, what is x? A vector of values. For example, in agriculture, what could be the vector? Weather condition, the soil strength, fertilizers which are used and their quality. And I told you water. So all these things, how much conducive is the weather for the crop, what is the strength of the soil, how much water and fertilizer used, this much quantity of yield is coming. This is going to train itself and generate this function. This function is what I'm going to call it as a model. So in machine learning, the result of the algorithm is a model. So what is model? Model is generated from the training data, the algorithm, which is not fixed, because I told you there is always certain assumption or some external factor which is going to change the result. The model is what we are supposed to create, where a lot of mathematics will come into picture, your statistics will come into picture, and that's what is machine learning all about. Once you have this formula, what you are going to do now? You are now going to provide inferencing data. That means you are now going to give x and you are going to get y. Here we call it as uh, y hat. It's y hat, which is nothing but the prediction. So right now I want you to understand the terms feature and label. For this feature, this is the label. For this feature, this is the label. This is training data. Training data is given into an algorithm. There are various algorithms which we are going to discuss next. And the algorithm, in addition to certain assumptions, is going to adjust itself so that it gets the accurate, as much as possible, accurate results. For this input, it will try to match this y. Definitely, it cannot do it 100% because there is no fixed formula. Some deviation might be there. So it will continue to keep adjusting itself till it gets the result which is in acceptable range. And once we have that, we can declare, okay, this is the model which is going to be used. And for the model, inferencing will be input and output is going to be y hat, which is the prediction. This is how machine learning actually works. So generally your data can be further divided into training data, test data, inferencing data. We'll talk a little more about it shortly. So now that you understand this is how machine learning models are created, which is purely on the basis of the relationship between these features. What are the types of machine learning? Very interesting. At the highest level, machine learning is categorized as supervised machine learning and unsupervised machine learning. Now, what is supervised machine learning? Where there are features and there is a known label. Label is known, then it is called as supervised machine learning. For the training data, which is nothing but features, the label is already decided. That's what is supervised machine learning. Are you with me? X1, X2, X3, X4, X5, then the value is Y. That is already known. So that kind of input, if used as the training data, then it is coming under supervised machine learning. Whereas unsupervised is what? There is no label. The unsupervised machine learning has to find out automatically the relationship between all the features and come up with some common categorization. Clustering we call it. Training data is unlabeled, no labels here. So for example, based on number of leaves, based on the height, based on probably the season of a plant, the plants are categorized. They're grouped, they're clusters created basically. So that's what is unsupervised machine learning. Here we have labels, here we don't have labels. When there are no labels, we generally do clustering. I will talk more about it. But supervised machine learning is further categorized into regression and classification. Regression algorithm, classification algorithm. Regression is always going to have a numeric value as its label. So maybe based on, if I take one more example, based on my vehicle engine, the capacity of the engine size, width, height, length. Maybe I will be able to predict how many kilometers my vehicle is going to travel. Number, that is, how many number. Likewise, I told you the crop example. What is the yield? Which will again be a number based on the temperature. How many ice creams are going to be sold? Number of ice creams sold based on day, season, and weather. Always the result or label is a numeric value. That's what is regression all about. Or if I take one more example, I want to predict what will be the value of a stock, or I want to predict what will be the value of land after 10 years in that region, or maybe the value of flat in that society, which can be on the basis of square feet, based on the number of bedrooms, and of course based on the locality, the social economic metrics of that particular region. The land cost or the flat cost is decided. That's again a number. So yes, supervised machine learning, where the label is always a number, is regression. Again, in regression, there are further division which we don't want to get into, this not being a machine learning training. But yes, that's what it is. Then we have classification. In classification, label is a category. One of the possible values, that's what is category. And that need not be number. It can be number also. But categorization is what is the outcome in case of classification, which is again further categorized as binary classification or multi-class classification. Now, what is binary? Am I diabetic? Am I not diabetic? That's it. Based on multiple parameters, the result is yes or no. That's it. Binary result. 0 or 1 is the only possible result. When I receive a mail, is the mail spam or not spam? Only two results. Or based on the content of the mail and so many other inputs, will the mail go into um, will the mail be read by the user or not? Will the mail be read by the user or not? That again, either read or not read. Finish. Only two answers. So that kind of classification is binary classification. Is or is not. That's it. And based on, I can say one more example. Based on certain factors, will a customer of a bank get a loan or will not get a loan? Or I can put it the other way. Should bank give the loan or not give the loan because of the person being defaulter? Will the person be a defaulter? Will the person be a not defaulter? Bank can probably want to predict and decide to give or not to give the loan. So that is binary classification. And then we have got multi-class classification, multi-class. There are different penguins. I want to predict the species based on measurement of their what do you call the beak. We predict the type of species, or let's say based on certain factors, we try to find out if the movie is a comedy or a horror movie or a romance or an action movie or a science fiction. One of these. Now we are not talking about Yes or no? We are talking about multiple possible values. That's what is multi-class, more than one class. Here, only one class. Yes or no? That's it. This class or that class. Multi-class. Based on the appearance and many other factors, find out what is the breed of the dog. Is it a German Shepherd, Husky, Golden Retriever? We find out the breed. So that's what is multi-class classification. Now, sometimes what happens is, this is little special case, in multi-class classification, there can be multiple labels. See, multi-class classification, one label. Movie is a comedy. But can the movie be comedy and horror? Possible, right? The genre of the movie is comedy and horror. Both combination, I'm saying. Multi-class, multi-label. Multi-class, single label. Multi-class, multi-label. Both the types are there. If inquiry comes to me, what is the probability of that person learning Java and Python? Based on various parameters, I know he will learn Java or he would learn .NET or he would learn Python, but somebody might learn both. So that's what is multi-class, multi-label, multi-class, single label. Two things in this category. Binary classification, one label only. So what is clustering then? Only features will be there. No label for training data. Only feature data will be inputted. The labels are not known, and then we are able to create a relationship between those features and categorize them. Create cluster of those related items. This actually goes to the next level, like clustering, and based on the clustering, I'll give you a live example where you go to Amazon, you select one particular product, it gives you related products. Users also purchased. It gives you that, right? That's nothing but unsupervised machine learning. In background, unsupervised machine learning algorithm is used, and they are creating the related items for a given item. They will put the item along with the other items in the same cluster, and they try to sell that also. I mean, that's how clustering or unsupervised machine learning is being used. So actually speaking, clustering in very similar to this multi-class, multi-label, right? Very similar. Here there is a label known. Here the label is not known. That's the major difference. That's it. Only similar features are grouped together to create a cluster. So here also, like, the classes only, right? Based on the customer properties, based on maybe the age of the person, the location of the person, based on probably the previous purchases the person has made, and some more factors, I may decide if this person is going to be a high value purchaser or low value purchaser. According to that, I will display the products. So are we categorizing only here also? We are classifying, right? High value purchaser, low value purchaser, or non purchaser, or a purchaser which will buy only if there is discount. That is also nothing but class. This is very close to multi-class. But here there is a predicted label which is used for training. There is no label here. Automatically you'll have to compute. So that's what is types of machine learning. And now we are talking about model training and evaluation. I think this I have already explained. My input data I will further divide into two types. I will use training data. Maybe if I have 100 records, I will say 90 records are training data and 10 records is my validation data. All this is history, data from the past. And generally what happens with the training data, we are going to create the algorithm, which is nothing but a model. And if the model is able to give correct result or not, we will verify using validation data. You have to actually verify. And when you verify, you are going to get the result. There is something called as evaluation metrics. There are multiple evaluation metrics actually. Accuracy, specificity, like that there are many evaluation metrics. So various evaluation metrics I am going to use and check how close is my prediction to the expected result. I know the result already, right? So I'll give this input and I'll get the result, and that result I'll compare with this. The y hat will be compared with this y. And if there is a deviation, I will reiterate and rerun the algorithm till I get the value very close to the actual. We keep adjusting. I told you, right? There is a factor which we have to keep adjusting. That factor will keep changing till we get the accurate result. So there are many evaluation metrics. Remember this word. There are many evaluation metrics using which we are going to test if my model is accurate, giving correct result or not for the test result. And once I know it is accurate, then I'm going to actually use my model for prediction. Otherwise, I'll not use my model for prediction. Evaluation metrics is not giving correct result. I'll not use. Very, very important. The role of evaluation metrics to get more accurate results. So I may run multiple algorithms, and one of the algorithm will be suitable to what we want. Whichever is getting me the best result, I'll use that. So one of the specialization of machine learning. Now machine learning we understood. Now if you go deeper into machine learning is what is called as deep learning. It's an advanced form of machine learning, we can say, which is purely based on how the human brain works. I mean, our brain is made up of multiple neurons, right? A lot of neurons are there in our brain. And these neurons all are like very densely connected with each other, through which the fluid is flowing. And that fluid, how it flows through the neurons, helps us in making decisions. Neurons fire in response to electrochemical stimuli. When fired, the signal is passed through the connected neurons. So that's what is human neural network. All the neurons in our brain are connected, and these neurons connect to each other, which help us to make a right decision. If I put my finger in the fire, I know it will burn. It will be painful. Maybe first time I did not know, so I put, and my brain got training on this. Why? Brain has created that flow of how the neurons are connected, and it remembers in the neurons that for this input and this action, this is going to be the result. Brain remembers like that. I'm not probably good at explaining how this brain works, but I hope you understand what I'm trying to say. You see something and you experience it and you remember it. How is that being remembered? All the connections in the neurons are there. Sometimes we forget the name of the person and we start scratching our bed. What is scratching the brain means? We are not having that one connection from here to here. That connection is not there. This data is there, this data is there, this is there, but this connectivity is not there. So we are trying to search which neuron should be used to reach that place where the name of the person is stored. That's what is human neural network. And artificial neural network is also going to work on similar lines. Here also we are going to have multiple layers of neurons. Multiple layers of neurons. Here also we have multiple layers of neurons. And these are going to help us to define deep nested functions. There will be function here. There has to be training done, like model has to be created, I told you, right? We have to find out if X is the input for this weight, where will it go? And then eventually reach the target. Based on weight, it is going to work. X is what? The vector. Each neuron is a function that operates on a input and a weight. This weight is going to play a very important role. There is something like activation function that determines whether to pass the output further or not. So some place it has to go and stop because we got the result. Otherwise it keeps going deep, and that's why it is called as deep learning. If I go a little more deeper on how is this working, let's say we have a requirement based on the input, which is penguin features. Think of x1 as the length of the penguin's bill. This is called bill. Length of the penguin's bill. The depth, x2 is the depth. Length of flippers, these are flippers. And let's say the weight of the penguin. These are four features: x1, x2, x3, x4. We want to predict what is the species of penguin, whether it is Adelie, Gentoo, Chinstrap. One of these species is the penguin. So how does it work? Now the feature vector, this x1, x2, x3, x4 is a feature vector which we call it as x, is fed into a input layer. This is input layer. In neural network, this is called as input layer. This is called as output layer. And this is called as hidden layer. Input, output, and hidden. So first thing which has to be done is a model has to be trained where for random weights, random numbers, this W is, let's think WA, WB, WC, WD, random values of weights, function is going to compute some result, and based on that result, it will go here or here or here or here or here. Each neuron, think of these nodes as neurons only. So based on what this function results, it will decide to go to the next one for different values of weight. So in short, every neuron is connected to all the neurons in the next layer. And this again has a weight which will connect to the next layer. And this path will be framed to reach a particular value. So you see now what happens is, for this input, the model is going to be trained in such a way that this is one input, like this millions of input you have to think of. The model is going to be trained in such a way that it is going to decide this weight for each neuron, each node. Weight gets fixed. For this weight, it goes here, something like this. Imagine we have an image which has 28 pixels, and we want to predict whether it is circle, square, or triangle. So this 28 into 28, each pixel is input now. X1, X2, X3, X4, X5, like that. All these are inputs. And in the first iteration, random weights are assigned. So X1 into 0.8 plus some X3 into 0.2, some weight. What will be the next node is decided. And this again goes as input to this, and one path will be decided, and one path will come, it will come to a conclusion that by this path we are able to reach here with this as the result. Think of this as a probability. Now chances are in first iteration the weights are given in such a way that it reached here. So immediately I'll check with my result, with my test result. I'll try to run and I'll say, is this value correct? No. Once I know it is not correct, I'm going to do backward propagation. I'll go back and I'll realign these weights. And these weights, when realigned, it can take a different path to reach a particular value. So we'll say, if this is circle, right? So this is supposed to be 0, this is supposed to be 0, this is supposed to be 1. Now you'll never get 0, 0, 1, 0, you'll never get. But if you are able to get something like 0.04, 0.06 and 0.9, you are more than happy. Total is 1. We know this is acceptable error. 0.1 is acceptable error. So if I know the highest values here, yes, this is circle. So something like that is going to happen. So I know if this is the input, I'm going to train the model so that I should get y as 1. But I'll not get y as 1. I'm going to get y as 0.7. but that is good enough to know that these two are very low values, so they cannot be correct, but this is the possible correct answer, Gen 2. We don't want to get into it. There are a lot of mathematical algorithms which come into the picture, and gate, a lot of those things come into the picture for deep explanation on this topic. But it's the process of inferencing. I mean, to get this model created itself, it can take days and months. It can take months also to create that model. There is something called as softmax algorithm, softmax function. Using softmax function, we reach the target. And we check, is the value closer to what is the correct answer? No, go back. Forward, backward, forward prediction, backward prediction. Continuously, forward propagation, backward propagation, back propagation, forward propagation, back propagation, and keep adjusting the weights. And at one point of time, the weights will be in such a way that it is getting me the most accurate. And the brain now remembers those weights. Weights got fixed, model got fixed. So to create model, it might take ages, but once the model is created, it can predict the values, and we can use it for various purposes, including stock market. But it can take huge amount of time. Or just imagine the power of our brain because of this. So that's what is deep learning all about. So what is machine learning in Azure? See, whatever we have discussed so far is all about machine learning. But what is machine learning in Azure? To perform all these algorithms, training data, computing the model, we need some compute power. Machines are needed, right? Some hardware is needed. Data has to be stored somewhere. So all this now Microsoft is giving us as ready-made infrastructure. It's a platform in Microsoft Azure for creating our models. So how does it work? There is something called as ML Studio. I mean, I want to give the demo in next session, but yes, we have got ML Workspace and ML Studio which have to be created. And through the ML Studio and Workspace, we are going to perform all the things which we discussed: training, deploying, creating models, and then inferencing, testing. All those things are going to happen in a machine learning studio. This is machine learning studio. This is metrics, you see, confusion metrics. What is true label? What is predicted label? So all this, Microsoft has given a ready-made beautiful platform for the data scientists who want to do machine learning. So we'll take an example, we'll take a demo of this in next session on how machine learning in Azure is. And from there, we are going to continue with the further topics on what are different AI services. Today's class was majorly on giving you introduction of what is AI and how is machine learning part of AI. AI is a bigger circle. Inside that, machine learning is one circle. Remember that. That's what I explained here. AI is just one part of, machine learning is one part of AI. But in AI, you also have computer vision, natural language processing, intelligent document intelligence, knowledge mining, generative AI. All these are different types of workloads. One by one, we have to learn all this at a high level. At a high level. So we'll do some practicals tomorrow and we'll get little better picture how predictions can happen with the models which are already there in Azure ML, or ability to create our own models also is there in Azure ML. The power of Azure ML we will see in next session. That's all for today. Yeah, I can take few questions. I may not be able to take a lot, but few questions, couple of them I can take. If you are on Teams, you can raise your hand and I'll call out your names for the questions. All good? Chalo. In such case,
So I had one query, sir. Actually, what are the how it will
who is
support for
talking to me?
administrators?
Who is talking to me? Raise your hand. Raise your hand. If you want to start talking, first condition is raise your hand. I should know the name. Avigna, go ahead.
Yeah. Sorry, actually that is my kids. What is that? Teams. So just what are the responsibility of administration and development? How it is useful
This is all
for
developers.
existing? Yeah.
AI will be used by developers. Administrators will not have much role to play in these. So you are going to use REST API in your programming, or you are going to make use of SDK and build software which will behave like humans and predict and make decisions. So not
Okay.
much for administrators in this particular kind of AI stuff. I mean, this training is good enough for you to understand what is AI. So you don't have to go to the next level AI 102. This is
Oh,
like
thank.
information you have now. That's all. You're not going to use this because this will not be anywhere directly helpful to you in administration. If you're talking about basic administration, you might use AI tools in doing administration. You may want to know if this is the kind of usage which you are getting today, how soon the hard disk is going to get filled. You want to predict. So you're a consumer of AI. You're not a developer of AI. If you're not a developer, Uma,
So one question is, we learned about the 6 things what Microsoft is bringing in as part of AI, right? The fairness or accountability and
yeah,
all that. So how do we have tools, or how do we measure that these are all definitely followed? I mean,
that's a
and
responsibility. It's a responsibility. It's like an agreement. When you are enabling these
Mhm.
features in Azure, you have to agree to those features. Like you have to be agreement is there, right? I agree to these terms and conditions. Like that, you put a check mark and then enable the feature. Like that, you'll have to do it. There's some
Okay,
things
okay,
which probably machine learning can automatically detect in the model. So if a particular parameter is being ignored, feature is being ignored, machine learning can predict that. But not all of them. You have to be also responsible for that as a human being. As a developer,
got
you
it.
have to take the responsibility.
Understood. Yeah, only the thing is just understanding, does AI, Microsoft, whatever tools or things, will it give or not? Yeah, I got it answer.
Hmm.
Thanks, Sandeep.
They just
Hi, sir. Sir, I just want to ask, like, which resource provider is there for machine learning in Azure?
which
A resource provider is getting used for all these machine learning related things in Azure.
I didn't understand. What do you mean by which resource provider? Oh, you're
Sir,
talking about
like
the
for app service.
subscription resource provider?
Yes, sir. For app services, we have
Oh, machine
Microsoft
learning. There
.NET
are. I mean,
resource.
I think I can give you that input when we do the training, but specifically, I don't remember. You just type machine learning there. Vision you type, machine learning you type, right? So
Okay.
that way you can figure out. I can't remember the provider names. Even for app service, I don't remember.
Okay, I think, sir, for app services, Microsoft.web is common
Right.
resource provider we are using. Yeah.
Yeah, but check up. I don't know. I mean, they automatically gets
Okay, sir.
enabled actually. So I never bothered about
Right, right,
it.
right. I will. Okay, I will find.
So guys, this was a kind of demo also for those who have not registered. I think almost all are already registered, but if not, you'll have to be registered for you to continue these sessions from tomorrow. These are not free. So connect with the backend team and decide if you want to. And definitely it's worth the amount which we are charging. Much, much, much more than what we are charging. So you can be assured of that. And we'll continue from here tomorrow. Thank you and take care. Bye bye.
Thank you, sir. Thanks for your information.
Thank you, sir.